Hello, I'm going to go over 9-3 reciprocal functions. I had started and then announcements happened, so here I start again. We have been doing these, finding where a function doesn't exist when we divide by a variable. And this is showing the numerator is a number and the denominator could be a function that stands on its own. So it has the x in the denominator. It's called a reciprocal function, which is the parent function. There's a vertical and horizontal asymptote, which I'll go over real quick. Those are lines where the function does not exist. It is called a hyperbola, which we'll go over, and where it doesn't exist, those are your excluded values. So the parent function of a reciprocal function is this, 1 over x. There are no transformations in the parent function. It has a vertical asymptote, and the vertical asymptote is a line that's vertical and is usually x, it is x equals, I put 0, but it's actually the number that crosses the x. And then it has also a horizontal asymptote, which is like this, and that is y equals and the number that it crosses at. It's a little different because you don't think horizontal y, but what that means, every point on that line, the y is equal to whatever number it is, and I'll go over that a little bit more. The name of the graph is a hyperbola. So you've seen a parabola. Now this is called a hyperbola. So here's a little summary of the function, the parent function. Hyperbola, asymptotes, intercepts none because it has no transformations, and it's not defined at x equals 0. So again, this is x equals 0, vertical line, vertical asymptote, and this is y equals 0, horizontal asymptote. So let's just jump in. You know your transformations, and you know outside if you have a number outside, plus or minus, it goes up or down, and that moves your horizontal asymptote. So your horizontal asymptote is based on the k value, and your vertical asymptote is based on where it doesn't exist in the denominator, where it's 0. So right here, example 1, x can't be 0, so you set your denominator equal to 0, done. So it doesn't exist, it's undefined for x equals 0. Just to get practice, this doesn't have a plus k, so your horizontal asymptote is y equals 0. Your vertical one is x equals 0. So this one's just like this one, but it's multiplied by 6, so it's stretched out a little more. Now this one, we're going to set the denominator equal to 0. Again, there's no k, so your horizontal asymptote is 0, y equals 0. So remember I showed you how to take the opposite. So x equals 7, and that's your vertical asymptote. X equals 7, so it's undefined where x is 7. This one, you're going to get this number, which change the sign, negative 4 divided by 3, negative 4 thirds, negative 4 thirds. Vertical asymptote is negative 4 thirds, and it's undefined there. So if you want to pause and do the check real quick, we did them in class. This one's easy, there's no plus or minus. X is 0, x is 11. Remember, negative 8 divided by 2, which is negative 4. And those are each the vertical asymptotes also, because that's where it's undefined. And there is no k. When I'm talking about k, it would be 19 over 17x minus 8. This would be your k. So none of these have this extra number outside that moves it up or down. Now we do. So now there's two things going on here. This moved up 2. So k is 2. So it has a horizontal asymptote of 2. And the range is every number but 2, except for 2. Now the domain, remember take the opposite, so 5 halves. The vertical asymptote is 5 halves. It doesn't exist there, so x is just not equal to 5 halves. It's equal to every other number. And that is it. When you graph these in the calculator, of course it won't put the dotted lines. Those are your asymptotes. Okay, it will not graph those. You could do Control T to get a table and see different values. You could also use a calculator to find the intercepts. Remember, these are called your zeros, and this is your y-intercept. Here we found finding the x-intercept. So for the x-intercept, your y is equal to 0. So you could also use the calculator, or you could do it this way. So you minus 2, multiply it by 2x minus 5, 2x minus 5. You get that. This equals 1. 4x minus 10 equals 1. Minus 10, and divide by negative 4, which is 9/4. That's your x-intercept. Same for the y, but you're going to put 0 in for x. So your y we're trying to solve. So we put in 0, we get 1 over negative 3 plus 2. So it's negative 1/3 plus 2, which is 1 2/3. Oh, this is 0, 1/5. That makes more sense. I was thinking a third is 0.6. 1/5 is 0.2, so you get 1.8. The x-intercept is 9/4, which I don't know that in a decimal. And this one is 1.8, or if you wanted to do that, that's 1 4/5. Okay, if you want to do a fraction. But when you're graphing, you actually need the exact value. So let's do the check. Vertical asymptote is 0 because there's no plus or minus there, so x equals 0. Horizontal is 1, positive 1, which is that one. Okay. Domain, x can be 0, y can equal 1. Let's find the intercepts. So first I'm going to put in 0 for x. This does not exist, so it never crosses the y. Now if we put 0 for y to find the x-intercept, get negative 1 equals 3 over x. We'll multiply both sides by x, or you could think of it cross-multiplying. Negative x equals 3, x equals negative 3. Okay, so there is no y-intercept because this does not exist. I mean y-intercept, I'm sorry. All right, analyze a reciprocal function. Ohm's law states that electric currents operate according to the equation I equals V divided by R. I is electrical current, V is electromotive force, R is resistance. Analyze the circuit. Electrical current of 110 volt curling iron in relation to resistance of its circuit. Because V is 110, we give 110 over R. The vertical asymptote is R equals 0, because that's just like our x. The horizontal asymptote is I equal 0, because we don't have a k. That's a plus 0 right here outside. Then move up or down. Make a table of values and plot. I'm going to plot right here. So instead of x, this is now R. Instead of y, this is now I. We have the asymptote, which is just our axes. Right here, right here. And then just graph it as best you can. It's always these two quadrants, positive, positive, and negative, negative. Unless it was a negative on top, then it flips it around the x-axis, reflects it. So this would go down and this one goes up. And there it is. They did a table if you want to do a table. Domain is r not equal to 0, all other values. The intercepts, I don't think there is one because we're dividing by r and we have nothing there. So it was I equals 110 over r, so there's plus 0. So if I put in 0 here, I get r times 0 equals 110, so your intercepts do not exist. Same if we put 0 in for r, we get I equals 110 over 0. So I can't have it divided by 0, so they don't exist. They never cross your x and y axis or your r and I axis. Positive where r is greater than 0, negative where r is less than 0. Symmetry around the x-axis. As r goes to negative infinity, your graph goes to 0. R goes to 0. And to the right, I goes to 0. Okay. I'm not going to do the next one because we're going to do the transformations now. So you know transformations, you should know them pretty well. H is inside the function, left and right. K is outside, up and down. Remember, H is always negative, so the H value is what determines left or right. A is multiplying, so you're stretching or compressing or reflecting and or. So let's look at this one. This one they gave you the graph and the function. So right here looking at the graph, I'm looking at the light green one, which is the transformation. So the light green one does not pass this, which is x equals negative 1. That's your vertical asymptote. And it does not pass this, which is x equals negative 2. I mean y equals negative 2, which is your horizontal asymptote. So your h is, since I have a plus 1, oh, see, I did match. I looked at the graph. So since I have a plus 1, my h is negative 1, which is left. Vertical asymptote at negative 1. K is negative 2, which is down. Horizontal asymptote at negative 2. Now, negative 4 means to reflect across the x-axis and stretch vertically. Domain x can't equal negative 1 and y can't equal negative 2. Instead of y, you could put g of x can't equal negative 2, your choice. Y values or the function at that point. So, sorry, my headset got moved. Okay, so now let's do this one. K is plus 3, so I'm going to have a horizontal asymptote at y equal 3. H is 1, because it's opposite of that, so x equals 1. That would make that 0. So domain x can't equal 1. Y can't equal positive 3. And all you do, since 1, there's no transformations, you just sketch it not to cross your asymptotes. That's it. That's a hyperbola. Okay, so those didn't ask about finding your x and y intercepts, but you could do, this one definitely has a y-intercept and an x-intercept. We could find it on this one. So x-intercept is when y is 0. So negative 3 equals 1 over x minus 1. So I'm going to cross multiply. 1 equals negative 3 x minus 1. 1 equals negative 3x plus 3. Negative 2 equals negative 3x. X equals 2/3. That looks about right. Now our y-intercept is when x equals 0. So I'm going to put y equals 1 over 0 minus 1 plus 3, which is negative 1. So y equals 2, because this is, you do the negative 1. 1 divided by negative 1 is negative 1 plus 3 is 2. I should have been right here, but I wasn't. Okay, now say you have the graph, but you want to find out what the h and k, what the values are, what the function looks like written out. So here's our graph. So looking at it, my vertical asymptote is x equals negative 4, which means my h is a negative 4. Now my horizontal is right here, and pay attention that the axis goes every 2, so this is y equals negative 2, so my k is negative 2. H and k don't change signs. They change signs when you put them in the function. So I'm going to write it right here. So we don't know our a. We have a negative 2. We have an x plus 4. Okay, now we need to find our a. Now the asymptotes, well, here we have it. H is negative 2, negative 4, and negative 2. They gave us this point. X is negative 3 and y is 3. So we're going to plug these values in for what we know. So this is our y, so we're going to say 3. When our x is negative 3, our h is negative 4, or you could say x plus 4 if you wanted. This is negative 2 is our k. The denominator is negative 3 plus 4, which is just a 1. So that kind of goes away. A divided by 1 minus 2, so I'm going to add 2. A equals 5. So our final function is that. Just plug in all the values and you will solve for your a, because you have an x, you have a y, you have h, and you have a k. Okay, so looking at this one. So this is also every 2, so I'm going to guess that my h is negative 1. So negative 1. So I know this is x plus 1. K, it went up 2, so it's a plus 2. Now a, we got the point, they gave us this point here, so I'm going to use that point, negative 2, 8. So I got 8 equals a over x plus 1 minus 2, but for ax, I'm going to put it negative 2. So if I add, no, this is a plus 2, sorry. If I subtract 2, I get 6 equals a over negative 1. Cross multiply, negative 6 equals a. So your final function is that. Okay, your questions are 1 through 10, 17 through 20. Remember, if you need more room, get a piece of paper, use a notebook. You should have a math notebook and do your work in there. Don't squish everything that it's illegible on in your workbook. Let me know if you have questions. Thanks.